Have you ever wondered how pigeons can find their way home from hundreds of miles away, even when landmarks disappear beneath the clouds and streets blur into unfamiliar patterns? What invisible compass guides them through vast, featureless landscapes? Could these birds be using a sense we humans barely understand, navigating by the very odors carried on the wind? This mysterious ability, hidden in the wings of a common city pigeon, opens a fascinating window into the secret world of animal navigation. But the truth is far more surprising and intricate than you might imagine. If you're curious to unravel this incredible story and discover what science is only beginning to understand, make sure to like this video, share your thoughts in the comments, and subscribe to the channel for more amazing bird facts. Also, don't forget to check out my ebook, The Ultimate Bird Facts Collection, 30 Surprising Truths, linked in the pinned comment below. It's packed with fascinating stories like this one to keep you inspired.
Pigeons have long fascinated humans for their uncanny ability to return home across unfamiliar terrains. For centuries, they were messengers bridging vast distances, trusted for their unerring sense of direction. Early scientists believed pigeons used landmarks or the sun to navigate. Yet, pigeons still manage remarkable feats on cloudy days or over the ocean where visible cues vanish. What hidden sense could explain this mystery? Recent research reveals that pigeons may rely on more than sight and magnetic fields. They follow scents carried by the wind, creating an olfactory map of their environment. But how does this invisible map work?
Scientists like Pappy propose that pigeons build an olfactory map by associating different smells with the direction of the wind at their home location. Just like humans use landmarks, pigeons learn the smellscape around their home. Odors carried by the breeze from forests, seas, and cities imprint a mental map. When released far away, pigeons sample local odors and compare them to their mental map to determine their direction. This olfactory navigation hypothesis explains why pigeons with impaired sense of smell lose their homing ability. But what specific odors act as navigational cues, and how reliable are these chemical signals over long distances?
Modern studies have identified volatile organic compounds, or VOCs, as candidates for pigeon navigation cues. These include natural compounds like dimethyl sulfide from the sea, terpenes from forests, and anthropogenic chemicals from urban areas. Using ultra-sensitive instruments, researchers detected regional gradients of these chemicals in the atmosphere, forming a kind of chemical map. Pigeons are thought to detect and analyze this complex mix of airborne molecules, a feat far beyond our technological capabilities. But how do these gradients remain stable enough to guide navigation?
Atmospheric models show that certain VOCs form relatively stable spatial gradients due to wind patterns and geographical features. For example, sea breeze cycles create predictable fluctuations in sulfur compound levels that pigeons can use as markers. These gradients can extend over large areas, giving pigeons a consistent sensory map even when visual cues are missing. This explains how pigeons can navigate not only in familiar territories, but also when released in new locations. Yet, this is just the beginning. There are still puzzles about how pigeons integrate olfactory cues with other senses. Pigeons don't rely solely on smell. They combine olfactory information with magnetic, visual, and possibly acoustic cues. Studies show that manipulating any one sense can partially reduce their homing ability, but not eliminate it. This multi-cue system makes pigeon navigation remarkably robust. Researchers have found brain activation related to olfaction during navigation tasks, supporting the importance of smell in this complex sensory web. But this raises new mysteries. How do pigeons weigh and prioritize these various inputs in real time? Classic experiments transported pigeons in odor-proof containers to unfamiliar sites, confusing their olfactory input. These pigeons showed impaired navigation compared to control groups, proving the critical role of smell. GPS tracking has added precision, revealing altered flight paths when olfactory cues are disrupted. Such studies cement the olfactory hypothesis, yet leave open questions about which specific odors matter most and how pigeons remember their olfactory maps. The remarkable capabilities of these birds continue to challenge scientists today. Across cultures, pigeons symbolize home, guidance, and devotion, ideas reflecting their extraordinary navigational skills. Historically, pigeons were vital for communication in wars and disasters, trusted to find their way when human knowledge failed. The scientific discoveries of their olfactory abilities shed new light on these ancient roles. Understanding the pigeon's sense of smell also illuminates broader questions about animal perception, migration, and survival strategies in nature. One of the most astonishing revelations is how pigeons' olfactory systems are finely tuned to detect extremely subtle airborne chemicals. Their nasal anatomy and brain structures appear specialized for this task, processing complex odor blends to build and recall mental maps. This molecular sensitivity allows pigeons to navigate despite environmental changes like pollution or weather shifts. These biological adaptations showcase evolution's intricate design and hint at senses humans barely comprehend. Today, environmental changes connected to climate change may be altering the chemical landscape pigeons rely on. Shifts in vegetation, industrial emissions, and atmospheric chemistry could impact olfactory cues, challenging pigeons' navigation. Understanding how these birds adapt offers critical insights into animal resilience and ecosystem health. It also raises questions about how human activity subtly influences sensory ecology beyond the obvious impacts. The most fascinating insight is that pigeons do not merely follow simple odor trails. They interpret a complex, dynamic chemical map akin to a living GPS made of smells. This invisible map changes with the wind, time, and environment, yet pigeons decode it with astonishing precision. This discovery not only rewrites what we know about bird navigation, but unlocks new ways to think about sensory perception across species. The humble pigeon, a common urban bird, possesses a mastery of the natural world that feels almost magical. Before wrapping up, remember to comment your thoughts, suggest new video topics, and share this video with fellow bird lovers. Don't forget to check the pinned comment for my ebook, The Ultimate Bird Facts Collection, 30 Surprising Truths, where you can dive deeper into more astonishing bird secrets.